morning, my dear students. Welcome back to our next chemistry class. I hope you all are fine. Last class we have discussed about empirical formula, molecular formula, how to determine the empirical formula of the compound from an elemental analysis, and all we have discussed. Today's class we are going to discuss about stoichiometry. You have learned from lower classes balancing the chemical equation. What is meant by balancing the chemical equation? Total number of reactants and products are, isn't it? From lower class we are discussing. What is meant by reactants? In a chemical reaction, equation we are writing is the left side what we are writing, that is nothing but reactants. After the reactants react, it will give the product that we are writing in the right side. Okay, so number of atoms present in the left hand side or reactant side is equal to number of atoms present in the right hand side or product side. Then that is called as a balanced chemical equation. Balanced chemical equation. Understood? Okay. Now what is meant by balanced chemical equation? That is nothing but in another word we are saying stoichiometry. So stoichiometry is nothing but it is one of the method of balancing the chemical equation. Balancing the chemical equation, or we can say the definition. It is the method of quantitative relationship between the reactants and the products in a chemical reaction or equation. In moles we are expressing. That is the quantity of the reactants and products. It can be expressed in terms of moles. Understood? In terms of moles or mass or volume we can mention. Understood? For example, I have taken combustion of methane is an example I have taken for explaining the balanced equation. Okay, what is the formula for methane? We have learned in 10th standard, isn't it? Homologous series. Methane, ethane, propane, butane you have learned, isn't it? So the formula for methane is CH4. This CH4 will undergo combustion. What is meant by combustion? What is meant by combustion? That is nothing but what is the support of combustion? Oxygen. That is nothing but burning. Understood? So methane will burn with the help of oxygen. It will give carbon dioxide and water molecule. Okay. Now both the side carbon atoms are same, hydrogen atoms are same, and oxygen atoms are same. Isn't it? So this is called as in what we can say balanced chemical equation, or we can say this is stoichiometric equation. Understood? As the stoichiometric equation, or it is say as nothing but what is called stoichiometric equation instead of saying balanced chemical equation. So what is meant by stoichiometry means it is nothing but in Greek word stoichio. In Greek word, what is the meaning for stoichio? They are saying element. Metro, nothing but measure. So to measure the quantities of or numerical relationship between the reactants and the products in a chemical equation or a balanced chemical equation is called as a stoichiometry. Understood? So it is a method of balancing the chemical equation. Okay, that is nothing but what? Stoichiometry. Now, in stoichiometry, how we can convert mass into number of moles. So suppose mass they have given means how it will be converted into moles. Moles they have given means how we can calculate the mass. Number of moles they have given means how we can calculate volume. And they have given volume means then how we can calculate the number of moles. This conversion and all we can calculate by using these formulas. Okay. So number of moles already have learned in 10th standard atoms and molecules lesson. For calculating number of moles there are totally 4 formulas. Number of moles is equal to mass divided by atomic mass. Suppose the mass of the atom they have given means, then the formula we have to use is mass divided by atomic mass. Suppose they are asking to calculate number of moles, but for the mass of the molecule they have given means, we have to use the formula mass divided by molecular mass is equal to number of moles. Number of atoms they are given means, we should use the formula for calculating number of moles. Number of moles is equal to number of atoms divided by Avogadro number. Last class, before class in that we have discussed Avogadro number value 6.023 10 to the power 23. Okay, and this way, suppose they have given the number of particles or molecules means, then they are asking to calculate number of moles. Then number of moles is equal to what? Number of molecules divided by Avogadro number. These are the four formulas you have learned already in 10th standard for calculation of number of moles. Isn't it? Same way, see here, number of moles is equal to mass divided by molecular mass. Mass of the substance they have given, we have to calculate number of moles means number of moles is equal to mass divided by molecular mass. Suppose they have given the number of moles, they are asking to calculate mass means mass is equal to number of moles into molecular mass. Understood? Molecular mass is nothing but the mass of that molecule. How we have to calculate that also you know already we have discussed in the last class. Molecular mass is nothing but sum of atomic masses of all the atoms present in the molecule. Understood? Okay, suppose they are asking to calculate volume. They have given number of moles means number of moles into what is that? 22.4 is equal to volume. What is 22.4? That is nothing but molar volume. First class we have discussed what is meant by molar volume. Volume occupied by 1 mole of any gas is called as in molar volume. The value is 22.4 liter. So number of moles into 22.4 is equal to volume. Or volume they have given, they are asking to calculate number of moles means number of moles is equal to volume divided by 22.4. That is, this will be equal to volume divided by 22.4. Okay, understood what I am saying? Okay, now next we are going to discuss is nothing but same stoichiometry calculation only. But in your book, they have given one example how to prepare kesari. For preparing kesari, you know what and all you need the ingredients. Rava you need, sugar you need, and ghee you need, and some nuts, fruits, something like that way. You need all these ingredients to prepare what? Kesari. Okay. So what they have given means, okay, 1 cup of rava they are taking. For that 1 cup of rava, you know in your home, your mother will be prepared for you kesari, isn't it? Okay. Suppose you don't know means hereafter your mother will prepare kesari means you go and see just how much they are taking and how much your mother is taking and adding rava and sugar and all. Okay. So sugar you are taking, that is rava you are taking 1 cup means you have to take the 2 cups of what? Sugar. And ghee somewhat we have to add, and what? Nuts, fruits and all we have to add. Okay. So 1 cup of rava we are taking and 2 cups of sugar we are adding, and some amount of what? Half cup of ghee, and what is that they are saying? That is 1/4 cup of nuts and fruits and all we are adding means, okay, we are getting totally 6 cups of kesari. 6 cups of kesari we are getting. Suppose if you want to, understand what I am saying? If you want to prepare, or you can calculate the amount of ingredients that are required for the preparation of 3 cups of kesari. Now for 6 cups of kesari, okay, we have taken the rava is what? 1 cup. And we have taken the sugar is double the amount of rava. So for 6 cups of kesari we are taking 1 cup of rava means, okay, by like this way itself we can calculate. For 6 cup of kesari you are getting, for that you are taking 1 cup of rava. If you want to get 3 cups of kesari, how much cup of rava you have to take? Easy calculation, half cup. Okay, but here we can like this way use the formula, this document. If you want to prepare 6 cups of kesari, you need 1 cup of rava. Therefore, 3 cups of kesari if you want to prepare means. Understand? 1 cup of rava divided by 6 cups of kesari is nothing but how we can say the sentence formation. To obtain or to prepare 6 cups of kesari, we need the ingredient 1 cup of rava. Therefore, 3 cups of kesari if you want to prepare. Okay, how many cups of rava you want? That is nothing but 1 cup of rava divided by 6 cups of kesari into 3 cups. So this cups of kesari will be cancelled and 3 and 6 will be cancelled means 2. So 1 by 2 cup of rava you need to prepare 3 cups of kesari. Understand what I am saying? Okay. Suppose now, okay, for preparing 6 cups of kesari, you need 1 cup of rava. Understood? From 3 cups of rava, how many cups of kesari you prepare? How we can, that is, we can give the relationship. See, for preparing 6 cups of kesari, you need 1 cup of rava. The question is, okay, from 3 cups of rava, how many cups of kesari you will prepare? So how we can take the relationship? To prepare 6 cups of kesari, we need 1 cup of rava. Therefore, there is nothing but what? From 3 cups of rava, how many cups of kesari we can prepare? So 6 cups of kesari divided by 1 cup of rava into 3 cups of rava. Because from 3 cups of rava, how many cups of kesari we want to prepare? That only we have to calculate. But already we have calculated from 1 cup of rava, how many cups of kesari is prepared? 6 cups. So 1 cup of rava, 6 cups of kesari is prepared. Understood? Which one you want? Understood? That should be that cups of kesari if you want means that should be in the numerator. So 1 cup of rava, from 1 cup of rava you are preparing 6 cups of kesari means then therefore 3 cups of rava, how many cups of kesari you will prepare? So 1 cup, 3 cups. So it will be cancelled means 3. 3 into 6, 18 cups of kesari we can prepare. 18 cups of kesari we can prepare from 3 cups of rava. Okay, understood? Now, explain this conversion by considering the combustion reaction of methane. What conversion? Already we have discussed, that is nothing but number of moles they are asking to calculate. Mass they have given means mass divided by molecular mass or mass divided by atomic mass. Volume they have given, they are asking to calculate number of moles. They are asking to calculate number of moles. Okay, so volume they have given, they are asking to calculate what? Number of moles means volume divided by what? 22.4. So like that way, by using this conversion, okay, we have to see the combustion reaction of methane. See here, methane will undergo combustion. Nothing but methane will react with oxygen. It will be produce what? Carbon dioxide and water molecule. Now it is not a balanced reaction. It is an unbalanced chemical equation. So we have to balance. 1 carbon, this side 1 carbon. Okay. But here how many hydrogen? 4 hydrogen. But that side 2 hydrogen only. So if we put 2 here means then hydrogen is balanced. Okay. Now here 1, that is O2. But here O2 plus 2. 2O. So not only 4O. 2 plus 2. 4O. So for that we are writing on here 2. Understood? So this is what? Balanced chemical equation. Now we have balanced this equation. Understood? Okay. So from this balanced equation, how we can say this one? 1 mole of methane combined with 2 moles of stoichiometric proportion, how we can write? 1 moles of methane combined with 2 moles of oxygen, it will give 1 mole of carbon dioxide and 2 moles of water. Like this is only we have to say stoichiometric proportion. Then mass relationship, how we can write? Mole into molecular mass is equal to mass, nothing but. Okay. So how many number of moles of methane? 1. So 1 mole into, what is the molecular mass of methane? How many carbon atom? 1 carbon atom. How many hydrogen atom? 4 hydrogen atom. What is the atomic mass of carbon? 12. What is the atomic mass of hydrogen? 1. Only 1 carbon, 4 hydrogen. So 12 plus 4 into 1. So 12 plus 4, 16. So 1 mole into 16 gram per mole molecular mass. Mole will be cancelled. So the answer is what? What is the mass of this carbon? That is methane, 16 gram. Understood? Now 2 moles of oxygen. So 2 into oxygen, nothing but O2. For 1 oxygen atom, what is the atomic mass? 16. And for 2 oxygen atom, 32. So 2 into 32, 64. Now 1 mole of carbon dioxide is produced. In carbon dioxide, 1 carbon and 2 oxygen atoms are there. Understood? So for 1 carbon, 12. For 2 oxygen atom, 32. For 1 carbon, 12. And for 2 oxygen atom, 32. So if we sum up means, what is the answer? 44. Understood? So 1 mole into 44 gram per mole. Mole will be cancelled. So 1 into 44, 44 gram. 2 moles of water. Already you know, you have learned in 10th standard. What is the molecular mass of water? 18. So 2 moles of water is removed. So 2 into 18, 36 gram. Same way, how we can say in terms of volume? How we can say in terms of volume? That is nothing but 1 mole. What we have learned already in 10th and 11th. Now in this lesson also Avogadro's hypothesis. What is Avogadro's hypothesis? What is Avogadro's hypothesis? Equal volumes of all gases. Okay, equal volumes of all gases contain equal number of molecules. So number of moles 1 means, what about the volume also? 1. So 1 into 22.4 is equal to 22.4. 2 into 22.4 is equal to 44.8. So 1 mole of carbon dioxide means 1 into 22.4 liters, which will be equal to 22.4. 2 moles of water means 2 into 22.4 liters, which will be equal to 44.8. Okay, understood? So based on the stoichiometric proportion, some problems they are given in your book. Some example problems also given, and exercise problem they are given in the book back. So first we'll see the example problems. I will explain. First one, how many moles of hydrogen is required? How many moles of hydrogen is required to produce 10 moles of ammonia? To produce 10 moles of ammonia. As per the stoichiometric equation, as per the balanced chemical equation, ammonia is prepared from nitrogen and hydrogen gas. Nitrogen and hydrogen gas. So nitrogen gas combined with hydrogen will give ammonia. That also 1 mole of nitrogen gas combined with 3 moles of hydrogen, it will give 2 moles of ammonia. This is the stoichiometric equation for the preparation of ammonia by Haber's process. Okay, so this is as per stoichiometric equation. What is the equation will come for the preparation of ammonia means nitrogen gas and hydrogen gas. 1 mole of nitrogen and 3 moles of hydrogen combined will give 2 moles of ammonia. But what is your question? How many moles of hydrogen is required to produce 10 moles of ammonia? To produce 2 moles of ammonia, how many hydrogen you require? 3. Then, therefore, 10 moles of ammonia if you want to produce, how many moles of hydrogen we will require? That we will see. Okay. So, as per stoichiometric equation, ammonia is prepared. Okay, from nitrogen gas and hydrogen gas. So to prepare 2 moles of ammonia as per the stoichiometric equation, To prepare 2 moles of ammonia, you need 3 moles of hydrogen. Therefore, to produce, what is the question? 10 moles of ammonia. To prepare 10 moles of ammonia, how many moles of hydrogen is required? So how we can write the relation? That is nothing but to prepare just 2 moles of ammonia. 2 moles of ammonia. You need 3 moles of hydrogen. Understood? Therefore, to prepare 10 moles of ammonia, NH3, ammonia formula is what? NH3. So to prepare or to produce 2 moles of ammonia as per the stoichiometric equation, you need 3 moles of hydrogen. Therefore, 10 moles of ammonia if you want to prepare, how many moles of hydrogen you need? Understood? Moles of ammonia cancel. 10 and 2 cancel means how many times? 5 times. So 5 into 3 is equal to what? 15. Understood? So to prepare or otherwise to produce 10 moles of ammonia, you need how many moles of hydrogen? 15 moles of hydrogen. Understood? Okay. The next problem. Calculate the amount of H2O water produced. Calculate the amount of water produced by the combustion of 32 gram of methane. Actually, we have discussed before this. Combustion of methane will give carbon dioxide and water molecule. Here the question is calculate the amount of water produced by the combustion of 32 gram of methane. Understood? So the methane is what they are saying. 32 gram of methane combustion will undergo combustion means how many amount or how much amount of water is produced. They are asking. For one mole of CH4, what is the molecular mass of CH4? 16 gram. Understood? So 16 gram of methane will undergo combustion. It will produce what? 2 moles of water. That is nothing but what is the molecular mass of water? 18. 2 into 18 what? Already we have discussed 36. So from 16 gram of methane or otherwise 16 gram of methane will undergo combustion. It will produce 36 gram of water. Therefore, 32 gram, what is your question? 32 gram of methane will undergo combustion. Understood? How much amount of water is produced? That is your question. So as per there is nothing but the relation how we can write. Understood? As per stoichiometric proportion, understood? 16 gram of methane will undergo combustion. It will give 36 gram of, what is that? Water. So how we can write? 16 gram of, because what we need, we want to calculate the amount of water. So 16, that is nothing but what we have to calculate? Amount of water. So from how much amount of water is produced from 16 gram of methane will undergo combustion? 36 gram. So 16 gram of methane will undergo combustion. It will give, as per the stoichiometric equation, it will give what? 36 gram of water. Therefore, understood? 32 gram of methane, CH4 will undergo combustion. Understood? Gram of methane cancel. 16 and 32 will cancel means 2 times. 2 into 36, what is that? 72 gram of water. 72 gram of water. Understood what I am saying? Okay. So, to calculate the amount of water produced by the combustion of 32 gram of methane. As per the stoichiometric equation, 16 gram of methane will undergo combustion. It will give 36 gram of water. Therefore 32 gram means. So 16 gram of methane will undergo combustion will give 72 gram of water. This is nothing but as per stoichiometric equation only we have to calculate like this way the mass. Understood? Okay. The next problem is nothing but here what they are given is how much volume of carbon dioxide is produced. How much volume of carbon dioxide is produced? Understood? When 50 gram of calcium carbonate. 50 gram of calcium carbonate. The question is how much volume of carbon dioxide? How much volume of carbon dioxide is produced when 50 gram of calcium carbonate? What is the formula for calcium carbonate? CaCO3 is heated. What is the formula for calcium carbonate? CaCO3. So CaCO3 is heated. Understood? It will undergo decomposition reaction and it will give calcium oxide by the removal of carbon dioxide. Already you have learnt. Okay, in 10th standard types of chemical reaction. That is nothing but what? Decomposition reaction. So calcium carbonate will undergo heat. It will give calcium oxide and carbon dioxide. Now the question is what? How much volume of carbon dioxide is produced when 50 gram of calcium carbonate? What is now? 50 gram of calcium carbonate is heated. 50 gram of calcium carbonate is heated. Now we want to first calculate, understood, molar mass of calcium carbonate. Molar mass of calcium carbonate. Understood? How many calcium is there in calcium carbonate? 1. What is the atomic number of calcium? 20. What is the atomic number of calcium? 20. Okay. So atomic mass of calcium is 40 plus. What is the carbon atomic mass? 12. Atomic mass of carbon is 12 plus. Totally how many oxygen atoms are present in calcium carbonate? 3 oxygen atoms. 3 into 16. What is that? 3 into 16. 3 into 16 which will be equal to 48. So if we add this 3 means what is the answer we are getting means 100. So 100 gram of calcium carbonate will undergo what? Heat. It will give what? Nothing but carbon dioxide. What is the molecular mass of carbon dioxide? 12 plus 32 which will be equal to 44 gram. Understand what I am saying? Okay. So if 1 mole of calcium carbonate will undergo heat, it will give 1 mole of carbon dioxide. That is nothing but 100 gram of calcium carbonate will undergo heat. It will give 44 gram of what? Carbon dioxide. What is the question is how much volume of carbon dioxide is produced? Okay, when 50 gram of calcium carbonate, 50 gram of calcium carbonate is heated completely under standard condition. Okay, so at STP, what is meant by standard condition? At standard, that is nothing but at STP, standard temperature and pressure. Standard temperature and pressure. 1 mole of carbon dioxide occupies 22.7 liters. At standard temperature and pressure, 1 mole of carbon dioxide occupies 22.7 liter. Understand what I am saying? What is the meaning for that? One means 100 gram of calcium carbonate. Understood? Okay. Will be heated means we are getting 22.7 liter of carbon dioxide. 7 liter of carbon dioxide. Understand what I am saying? Once again I will repeat now. Your question is how much volume of carbon dioxide is produced when 50 gram of calcium carbonate is undergo heat? completely under standard condition. Completely to undergo heat means it will be converted into its product. Okay. Under standard temperature and pressure. So what is that? First we have to calculate the molecular mass. Molecular mass of calcium carbonate as per the stoichiometric equation, 1 mole of calcium carbonate will undergo heat. It will be 1 mole of calcium oxide and 1 mole of carbon dioxide. Now how we can calculate the molar mass or molecular mass of calcium carbonate? 1 calcium 40 atomic mass, carbon 12 and oxygen 3, oxygen atom 48, so 100 gram. So 100 gram of calcium carbonate will undergo heat. It will produce 44 gram of carbon dioxide. But the question is, how much volume of carbon dioxide is produced? How much volume of carbon dioxide? But the condition is under standard temperature pressure. Under standard temperature and pressure, 1 mole of carbon dioxide occupies 22.7 liters. Or 22.4 liters can carry. This okay, 22.7. So now how we can write the relation for this one? 100 gram of calcium carbonate will undergo heat. Understood? It will produce 1 mole of carbon dioxide, that is nothing but 22.7 liter of carbon dioxide. Okay, therefore 50 gram of, what is that they are saying? Therefore 50 gram of calcium carbonate. 50 gram of calcium carbonate will undergo heat. We have to calculate. So cancel means what we are getting? 2. Understood? So this 2 and this will be cancelled means we are getting the answer is 11.35 liter of carbon dioxide. 11.35 liter of carbon dioxide. Understand what I am saying? Once again repeat more. How much volume of carbon dioxide is produced when 50 gram of calcium carbonate is undergo heat under standard temperature and pressure? As per the stoichiometric equation, CaCO3 gives CaO plus CO2. That is 1 mole of calcium carbonate. What is the molecular mass of calcium carbonate? 100 gram. It will produce 1 mole of what? Carbon dioxide, nothing but 44 gram of carbon dioxide. At STP, what is that value we will see? We will say 1 mole of carbon dioxide occupies 22.7 liter. 100 gram of calcium carbonate produce 22.7 liter of carbon dioxide. Therefore, 50 gram of calcium carbonate. So we will cancel means we are getting the answer is 11.35 liter of carbon dioxide. So this is the answer. Okay.